Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Now, if you've been following the videos, you'll know that we just finished the arithmetic section for Meet 1. So now we're moving on to algebra for Meet 1, which is probably the hardest category out of any. It's also the fifth and final category for Meet 1, so after this we're doing Meet 2. First, we need to look at this material, so let's dive right in. So first let's start with an intro to algebra and some algebra basics. If you don't know, algebra is all about solving equations with variables in it and using variables to find certain values or to calculate certain values. Now, if you watched my final video in the Geometry Meet 1 section, then these next few slides might be a review for you. But if you haven't, then that's okay too. So first, a variable is a non-number symbol that represents a value, such as x, y, or z, or it can even be something such as angle ABC. So in geometry, when we represent angles, we represent them like this. We have the angle sign, and then we have whatever the letters that form the angle are. This is considered a variable because it's representing some value. Could be equals to 30, could be equal to 50, we don't know. But that's why we have variables in the first place, to hold the value or hold the place of some number that we don't yet know what the value of it is. So next, we use variables by representing certain values with them in equations. So for example, if you knew that two variables, x and y, add up to 180, the equation you could create with this is x plus y equals 180 to represent the scenario. And most of the time, you're going to end up seeing these variables in equations, and you're going to have to either simplify the equation to find the value of the variable, or plug in values of the variable to see if the equation makes sense, or what the final value of the equation is. So the way that we find the value of a variable in an equation, so if it's in an equation and we don't know what it is, we have to do something called isolating the variable, which means that we need to get the variable on its own side of the equation. So the format of the equation is variable equals some number, such as x equals 34 or y equals 27. And in both of these examples, we have variables, which are x and y, right here and here. And it's equals, which is in the center always, and then some number, which are 34 and 27. And we simplify very complex equations down to this in order to find the values of those variables. And then the way that we isolate the variable is by using algebra. So that's where algebra comes into play, and that's what I'll be teaching you in this lesson. So in order to use algebra and isolate the variable, there are a few fundamental rules and basic properties that you need to know about equations. So I'm going to start with the most important one by far, and that's the equation equality rule, which says that if you do the same thing to both sides of an equation, then the equation will stay equal. So here I have an example. My equation is pretty simple. It's 5 equals 5, right? Anyone can write that equation, but here's how the equation equality rule works. So if I decide to do something to one side of the equation, like here I added 3, so it becomes 5 plus 3. If I do the same thing to the other side of the equation and add 3 as well, then the equation will stay equal because this is 5 plus 3 and that's 8, and then this is also 5 plus 3 and that's 8. And that just simplifies to 8 equals 8. So that's pretty simple. It also applies to multiplication and division and subtraction. Here, if I'm multiplying both sides by 19, then 5 times 19 is 95 on this side, and then if I multiply this 5 by 19, it also becomes 95. And I did the same thing to both sides of the equation, and the equation stayed equal because of it. Why this is important is because the same rule applies to variables. So when you do things to certain sides of the equation, you can actually change the format of the equation while still making sure it's equal when you have variables in it. So if I had the equation here, 8 equals y, if I subtracted 3 from both sides, so I have a minus 3 and a minus 3, this side becomes 5 because 8 minus 3 is 5, and this side becomes y minus 3. So it simplifies to 5 equals y minus 3. But I know this is still equal because of my equation equality rule. And because we know that 8 equals y, so if we just put an 8 here instead, it would still be 8 minus 3. And then same thing here. If I multiply by 4 on both sides, I have 4 times 8 here and then 4y here. The equation stays equal because this simplifies to 32. And then this would simplify also to 32 if you figured out that 8 was actually y. And so we could just say 32 equals 4y without actually having to calculate, because we know the equation stays equal when we did the same thing to both sides of the equation. So now to a few other algebra properties, which are also very important for eventually isolating the variable and finding the value of variables in equations. So the first is the commutative property of addition and multiplication, which says that the orders in which numbers are added or multiplied does not matter. So here I have two examples. First, I start with my equation 5 plus 3 plus 4 plus 2 equals 2 plus 4 plus 5 plus 3. So on both sides of this equation, you're adding the same numbers, 5, 4, 3, and 2, just in different orders. But it doesn't matter which order you add them in, because they're always going to end up with the same result. On the left-hand side, it adds up to 14, and on the right-hand side, it also adds up to 14. So that's the commutative property of addition. And then in my second example, I have the commutative property of multiplication, which I use a little asterisk here for multiplication. This also means that you're multiplying numbers as well if you don't recognize it instead of an x. So I'm multiplying 78, 43, and 2. And here I have it in a different order. It's 2 times 78 times 43. Well, our commutative property says that it's going to end up as the same result. And so both sides of this equation are equal. So that's the commutative property of multiplication. But be careful. This property doesn't work with subtraction, and it doesn't work with division. Let me give you an example. If I had 5 minus 3 as one side of the equation, it does not equal 3 minus 5. Because 5 minus 3 is 2, and 3 minus 5 is negative 2. So you can only rearrange numbers that you add or multiply, and put them in a different order and still get the same result. But you can't rearrange the order in which you subtract or divide. So the next thing is the order of operations, and you might already know this. The order of operations is the order that you do operations in an equation. And that goes PEMDAS, parentheses, exponents, multiplication and division, and addition and subtraction. Notice how I say PEMDAS here, but when I spell it out in these parentheses, I have multiplication and division as the same priority, and I have addition and subtraction as the same priority. So what this means is when you have an equation, you do whatever's in parentheses first. You always have to. And then you always have to do whatever has exponents second. And then you either do your multiplication or division first. It just matters which comes first in the equation. So if my equation was 5 divided by 5 times 7, then I would do 5 divided by 5 first, and then that times 7 second. And then same thing, if I had 5 times 5 divided by 7, I would have to do 5 times 5 first, and then that divided by 7 after that, because they have the same priority. And then same thing with addition and subtraction. They also have the same priority in the same way as multiplication and division. You just do whichever comes first out of the two in your equation. But you do have to do multiplication and division before addition and subtraction. And then the last thing, which is extremely important, is the distributive property, which says that a number multiplied by an expression in a parentheses can be distributed. So here I have an example. So here's an expression in a parentheses, x plus 5, right? So I have my parentheses and I have x plus 5. And outside of it, I have the number 3. Since this 3 is right next to this parentheses, it means that it's being multiplied by whatever's in the parentheses. So this simplifies to 3 times x plus 5. Well, the distributive property says that we can distribute the multiplication to each term, which means I can multiply 3 by x, and I can multiply 3 by 5. And that's what I'm doing here. I turn it into 3 times x plus 3 times 5. And then that simplifies to 3x plus 15. And then one last note about the distributive property, which I forgot to include the first time. You always have to keep whatever operation you do in the middle of the parentheses as your operation. So what that means is I have x plus 5 here, and I add x and 5, right? So I have a plus here. So when I distribute by multiplying 3 by x and by multiplying 3 by 5, it has to become 3 times x plus 3 times 5. It can't be minus 3 times 5 because I started with a plus. And then it would be the same thing if I had an equation like this, whereas 3 times x minus 5. If I were to distribute this, it would have to become 3 times x, so 3 times x minus 3 times 5. because I was originally subtracting 5 from x, so I need to keep whatever operation I have in the middle of these two terms. So finally, to isolating the variable. Isolating the variable, if you don't remember, is what you do in order to find the value of a variable in an equation when you don't know the value at first. So in order to explain this, I find the best way to do it is through example. So I have an example equation here, and I'll be going through it, explaining how to isolate the variable in this one. So my equation that I'm using is 3x plus 2 equals 5. My goal is to find the value of x. If you remember what isolating the variable is all about, it's about getting the variable to one side of the equation and then simplifying, so you end up with the format of the equation being variable equals some number. So here that's not what I have. I have 3x plus 2 equals 5. So it's too many of the variable plus some number equals some number. So I need to get rid of those numbers so I can get it down to variable equals some number, or x equals whatever it is. So the way that I need to do that is first get the variable on its own side of the equation. I want the 3x all on its own. And so in my original equation, I have 3x plus 2 equals 5. So my goal is to get rid of this plus 2 on this side of the equation. And the way that I do that is by using the equation equality rule to change the equation, but keep the equation equal at the same time. So if I want to get rid of this plus 2, the way you do it is you subtract 2. You do the opposite operation, and then you have to do that to the other side as well. And I'll explain why in a sec, but just trust me, this is going to work. So if I have 3x plus 2, and then I subtract 2, then that becomes plus 2 minus 2, or 3x plus 0. And so that just leaves me with 3x all on its own. And then if I simplify the other side of the equation, as in 5 minus 2, because I still need to do the same thing to both sides, 5 minus 2 is 3. So I've done one operation to both sides of the equation using my equation equality rule, and I've simplified this equation from 3x plus 2 equals 5 to 3x equals 3, and successfully gotten the variable on its own side of the equation. Now you might be wondering how I figured out what to do and how I got rid of the plus 2 in the first place. Let me explain through another example. So if I had the equation 5x plus 9 equals 12, then the way I get rid of the plus 9, because I want this 5x to be all on its own on the left side, so I need to get rid of this, is by subtracting 9. I have to take whatever operation you're doing, so this is addition here, and do the opposite operation of the same number. So it becomes plus 9 minus 9. And then do that to the same side, or to the other side of the equation as well, to keep it equal. And the reason that this works is because if you do the opposite operation, for addition it would be subtraction, for multiplication it'd be division. But if I did the opposite operation of addition by subtracting 9 after I add 9, that just leaves me with 0. If I just simplify these two terms here, plus 9 minus 9, that just simplifies to 0, which means I only have 5x left. You're essentially just canceling out whatever you want to get rid of. So I subtract 9 after I add 9 to cancel out the plus 9 that I originally had. Then on this side of the equation, I just need to make sure to do the same thing, otherwise my equation won't be equal. And so 12 minus 9 equals 3. So you're essentially just canceling out a value that you don't want on one side of the equation, but then moving it to the other side of the equation, so you're keeping the equation equal at the same time. So the next thing that you do after you have the variable on one side of the equation is you have to simplify it down, so it's variable equals some number. Here we have 3 times the variable equals 3 times whatever number it is, but I need to get it down just to one value of the variable. And the way that you do this is typically through multiplication or division. So here I have 3x equals 3. What 3x means is 3 times x. So in order to get rid of that 3 in the 3 times x, I need to divide by 3, right? So let me write this up for you. 3 times x. And if you're unfamiliar with this symbol, we use this dot to represent multiplication, because a lot of the times we're working with variables like x. And if I wrote 3 times x like this, sometimes it can get confusing on exactly what is multiplication and what is a variable. So we use a dot instead a lot of the time when we're talking about equations. So this is 3 times x equals 3. So if I get rid of this 3 by dividing both sides of the equation by 3, and then divide it by 3, then this is going to simplify right here to 1. So this equation becomes 1 times x equals 3 divided by 3. And 1 times x is just x on its own. So that's how we get x all on its own, so we can have variable equals some number. And our last step is just simplify this part of the equation. So 3 divided by 3 is 1. So now we've managed to get the equation down to x equals 1. And that's how we find the value of a variable. That's how we isolate it. We first need to make sure that we get all the variables to one side and all the constants, which are any non-variables, to the other, and then simplify down the variable so there's just one value instead of multiple values of it. So this question is a little bit harder than some of the other ones that I went over to explain how to isolate the variable, but it's really good review. And if you want to try it, I'll give you a few seconds to pause the video, and then I'll explain how to find the answer. So the correct answer to this question was that x equals 3. So this equation has a variable in it, and in order to find the value of the variable, we have to isolate it, get it to this own side of the equation, so it becomes variable equals some number, or x equals some number. So our first step is to get all of the variables to their own side of the equation. So then we can simplify it down to just one value of that variable. So our equation here is 17x minus 14 equals 17 plus 4 times x plus 2. So the first thing that we want to do is simplify our equation a little bit just to make it easier to use our equation equality rule on. Because adding and subtracting 4 times x plus 2 would be pretty difficult because we don't actually know what x plus 2 is. And it's really hard to think of a way in order to get this on its own. So in order to do that, we need to use the distributive property. If you remember what the distributive property is, it's just multiplying terms in an expression that's in parentheses by whatever's outside of a parentheses. So here we have 4 times x plus 2. Well, our expression inside the parentheses is x plus 2, and then on the outside is just 4. So we're multiplying 4 by x plus 2. The distributive property says that we can distribute the multiplication to each term. So we can turn this into 4 times x plus 4 times 2. Because remember, we need to keep whatever symbol's in the middle here, which is an addition symbol. So we can simplify this to 4 times x, so 4 times x plus 4 times 2, 4 times 2. And then we can simplify that down to just 4x on its own plus 8. And so now we have a constant here, and we have a variable here that's not inside a parentheses. So now we can use our equation equality rule a little bit more easily on it to simplify this equation. So if I know that this section equals 4x plus 8, then let me rewrite our equation to make it more simple. So this turns into 17x minus 14, so this side of the equation doesn't change because we didn't do anything to it, equals 17 plus 4x plus 8. So now our goal is to get the variable on its own side of the equation, or all of the variables on their own side of the equation. I'm going to pick the left side to have the variable on, so it's variable equals some number. So on the left side of the equation, I have 17x minus 14. So my first step should be to get rid of this minus 14 on this side, and then move it to the other side somehow. Well, the way I do that is I have to add 14 to both sides of the equation. Because if I have 17x minus 14 plus 14, then the minus 14 and plus 14 simplify to minus 0. And then 17x minus 0 just leaves me with 17x on its own. So if I rewrite my equation as 17x minus 14 plus 14 equals 17 plus 4x plus 8, and then plus 14 as well, because I have to do the same thing to both sides of the equation, then I can simplify this side down to 17x and then equals 17 plus 4x plus 8 plus 14. And then I probably should have done this at the beginning, but it doesn't really matter when you do it. It just might make it a little bit easier if you do this now. You just want to simplify the addition on the right-hand side of the equation. So this is 17x equals, then if you just add 17, 8, and 14 on this side of the equation, it just becomes 39 plus 4x. 17 plus 8 plus 14 is 39. So now my equation is 17x equals 39 plus 4x. Well, I got the variable on the left-hand side of the equation all on its own. So am I done this step? I'm actually not done this step, because on the right-hand side of the equation, I still have a plus 4x. And I want it to be all the variables on one side of the equation and all of the constants on the other. So just because I have only variables on one side of the equation doesn't mean I'm finished. I still need to somehow move this plus 4x to the left side, or get rid of it on the right side. And then the way you do that is you have to subtract 4x from both sides. Now this may be a little bit confusing, but it's the exact same concept that we use with constants. If I'm adding 4x and I subtract 4x, then that just leaves me with 0, because the two operations cancel each other out. So this equation turns into 17x minus 4x equals 39 plus 4x minus 4x. And then 17x minus 4x is 13x. And then 39 plus 4x minus 4x, it's just 39 on its own. So 4x minus 4x is 0, and that's 39 plus 0, and then that's just 39 as a result. So finally, I've gotten this equation down to 13x equals 39. Now I have all my variables on one side of the equation and all of my constants on the other side of the equation. So I can do my second step. Simplify it down so I only have one value of the variable, so it becomes variable equals some number. So I want it to be x equals some number. So here, since I have 13x, which means that I'm multiplying x by 13, in order to get rid of that 13, I have to divide by 13. The opposite operation of multiplication is division. So if this is 13x divided by 13 equals 39, and then also divided by 13, because you have to do the same thing to both sides, then this becomes x, and then this side becomes 3. This 39 over 13 is 3. So this next part of the algebra section is a little bit more straightforward than the first part. It's evaluating expressions, which means that if you get an expression, some questions are going to ask you to evaluate it for certain values of the variable. So an example of this would be if they gave you the equation 13x plus 2y plus 3 times x plus y, they want you to find the value of this expression if x equals 3 and y equals 2. So you don't actually need to find the values of the variable, you just need to use the values of the variable to simplify this expression. So the way that you do this, and it's the easiest way and probably the only way, is by using something called substitution, which means replacing a value in an equation with an equal value. So if I know x equals 3, then I can replace all x's in the equation with 3. And if I know y equals 2, then I can substitute in 2 for y because they're equal, and that's replacing an equal value with an equal value. So in this example, I would turn 13x plus 2y plus 3 times x plus y into 13 times 3, because x is 3, and make sure you put these in parentheses, because otherwise you might get confused or you might not know exactly what to do first. This is definitely a problem that I had. I sometimes don't put substitution values in parentheses, and then I end up screwing up the equation, and it's really bad. So just make sure you put these in parentheses so you know exactly what you're substituting in. So I have 13 times 3, because x is 3, plus 2 times 2, because y is 2. Then finally plus 3 times 3 plus 2 in parentheses, because x plus y is the same as 3 plus 2, since x equals 3 and y equals 2. And then from there, it's just simple arithmetic. You just have to simplify the equation down. So I turn it into 39 plus 4 plus 15. And I simplified this down just pretty quickly. 3 plus 2 is 5, times 3 is 15. And then all I have to do is finish adding that to get my answer of 58. And then just to review this concept, I have one question that you can try. I'll give you a few seconds to pause the video if you want to, and then I'll explain the answer. So the correct value of this expression was 52. So when I look at this expression, I see a whole jumbled mess of variables. I have 12x minus 3 times 4y minus 3 plus 2y. So I have two terms with y in it, I have two constants, and then I have an x. And I notice that the values of my variables are 4 and 1/2. And so the reason that's problematic is because it can be difficult sometimes to substitute in values of fractions in immediately, especially when you have to do a lot of operations on them, and especially if you're unfamiliar with how fractions work, then it might make it really difficult to put the value of y in as 1/2 immediately right from the start. So one way to mitigate this, or to make it a little bit easier to deal with, is to simplify your expression first before you substitute in values. Because it doesn't actually matter when you substitute in your values, you're going to end up with the same end result. So if I change up this expression first, making sure it at least has the same value, and then put my variables in as the actual numbers that they are, then I'm still going to get the same end result, and it'll make it easier for me to solve the expression. So let me write out my expression here. So I have 12x minus 3 times 4y minus 3 plus 2y. Plus 2y. The first thing that I see in this expression that I need to simplify is this right here. I have something that I can use the distributive property on. I have an expression inside of parentheses, which is 4y minus 3, being multiplied by a number outside of the parentheses, which is just a -3. And so you may not have encountered this before, but this is really, really important. If you have an expression in a parentheses being multiplied by a number outside, so something you could use the distributive property on, if that number that you're multiplying by is being subtracted by another number, consider it as a negative number. So when I multiply this by each individual term in the parentheses, I'm going to consider it like I'm not multiplying by 3, but I'm multiplying by -3, since I'm subtracting 3 here. So with that considered, let me do the distributive property, multiplying -3 by 4y into -3 by 3. So first, -3 times 4y is -12y. And if you're unfamiliar with how negatives work, it's pretty simple. If you multiply a negative number by a positive number, it's going to end up as a negative number. If you multiply two negatives by each other, they're going to cancel each other out and just end up as a positive number. And then obviously, if you multiply two positives by each other, that also ends up as positives. So here we're multiplying a -3, by a positive, 4y. So it leaves me with a negative number, which is -12y. And then next, I have to multiply -3 by 3. Well, I'm multiplying a negative by a positive, and 3 times 3 is 9, so that's going to leave me with -9. And then the last part that you have to remember is to keep the symbol in the middle. So since I'm subtracting, I put a subtraction sign here. So this becomes -12y minus -9. And then there's one last step we can do to this to simplify it. Turn it into -12y plus 9. And so if you're wondering how to simplify this, if you ever subtract a negative number, just turn it into adding that number. So minus -9 turns into plus 9. And then the way I remember this is I think of it as these two lines here, so minus negative. I can take this line and put it here to turn it into an addition symbol, like that. So I always think when I see two lines, it means I'm adding. So now I have -12y plus 9 here. So if I rewrite my equation with that in it, it becomes -12x and then minus 12y plus 9 plus 2y, which I had at the end right here. So now this is my equation. Before I substitute in values for y and x, there's one last step of simplification I can do. And that's something called combining like terms. And you may have already figured this out. But if I'm subtracting 12y and then I'm adding 2y, I can combine those to turn it into minus 10y. If you're confused on how this works, let me explain it as if you're using constants. So if my equation was 3 plus 5 plus 2x plus 2x minus 4, I I can do 3 plus 5 first, which simplifies to 8, because they're both constants, so I can do those operations on them, and then I can subtract 4 from 8 before I add 2x. So 8 minus 4 becomes 4, so it just becomes 4 plus 2x. So since I had 3 constants here, I combined like terms, and like terms is when they're the same type of value. So I had 3 constants, and those are all the same type of value because they're constants. I was able to combine the operations done on them to simplify the equation. So same thing here. I have minus 12y and plus 2y. So I can combine it like I would combine any constants to get minus 12 plus 2 as minus 10. And then just make sure I add y at the end. So 12x minus 10y plus 9 would be my final expression that I can't simplify down anymore. Because here I have 12x, I have minus 10y, and then I have plus 9 here. And I can't combine anything from there. I can't simplify it. So now this is where I substitute in my values. So first, x is 4, so this becomes 12 times 4. It was previously 12 times x. Then I do minus and then 10 times 1/2, because y was 1/2. And then I keep my plus 9 here because it was just plus 9. Now if I simplify the 12 times 4, that gets me 48. Then minus 10 times 1/2, and that's 5, because 10 times 1/2 is 5, because 1/2 of 10 is 5. That's how fractions work. So if I had 10 times, or that's not a good example. If I had 100 times 1/4, then it'd be 25, because 1/4 of 100 is 25. So since I have 10 times 1/2, it becomes 5, because 1/2 of 10 is 5. And then finally plus 9 here. And then when I simplify this, 48 minus 5 is 43. And then plus 9, and that leaves me with 52 as my final answer. And now to review what we learned this lesson, we started by going over the algebra basics and just an intro to algebra, what it's all about. So first we learned that a variable is a non-number symbol that represents a value, such as x, y, or z, which you see in a lot of equations. And then you can even represent things like angles as variables, such as angle ABC, because it's a non-number symbol that's representing a value. We learned how to use variables, which is by creating equations with them based off what we know about them. So we could say if x and y add up to 180, you could write x plus y equals 180. Then we learned how to find the value of variables, which is isolating the variable to get into the form variable equals some number, and we had a few examples. And then we learned that we have to use algebra to actually isolate the variable. So before we talked about isolating the variable, we went over a few algebra basics and how to use algebra in equations. And so the first was the equation equality rule, which says that if you do the same thing to both sides of an equation, the equation stays equal, which is extremely important for all algebra purposes. And then we had a few examples here where we started with 5 equals 5, and then we added 3 to both sides and multiplied by 19 on both sides, and the equation stayed equal. And then we learned that we can apply the same rule to variables. So if we had 8 equals y, we could subtract 3 from both sides or multiply 4 by both sides, and the equation would still stay equal. Next, we talked about a few other algebra properties, starting with the commutative property of addition and multiplication, which means that it doesn't matter which order you multiply or add numbers, because it'll always give you the same end result. But we also learned that it does matter which order you subtract or divide numbers, because that won't give you the same end result if you change that up. Then we learned about the order of operations, which goes PEMDAS, which means parentheses, exponents, multiplication, and division, and then addition and subtraction. And then we talked about how you have to do multiplication and division as the same priority. So whichever comes first out of the two of them, you do first. And then the same deal with addition and subtraction. And then finally, we talked about the distributive property of multiplication, which means that a number multiplied by an expression in parentheses can be distributed. So 3 times x plus 5, where x plus 5 is the expression in parentheses, becomes 3 times x plus 3 times 5. You're multiplying the outside number by each individual term and keeping the symbol in the middle. Then we talked about how to actually use all these techniques to isolate a variable. So the first step to isolating a variable is moving all the variables to one side of the equation and all of the constants to the other, so you can simplify it down from there. So we had this equation 3x plus 2 equals 5. We subtracted 2 to get rid of the plus 2 on the left side. So we ended up with 3x equals 3. And we got the variables all to one side and the constants all to the other. And then we learned that the second step is just to simplify that down so there's only one value of each variable. So your format is variable equals some number. So in order to simplify 3x equals 3, we divided out the 3 and 3x and got x equals 1. And then we did one review question to go over isolating the variable. And we found that this was equal to 3. So next we talked about how to evaluate expressions, which means when we get an expression and we get values of a variable, how to find the value of the expression. And we learned that the simplest way to do this was just through substitution, which means replacing the values of the variable with the actual values that they equal. So replacing x with 3 and y with 2 in this example. And then we just went through the steps in order to solve this expression and find it was equal to 58 if we substituted in 3 for x and 2 for y. And then finally, we did one last review question where we evaluated this expression if x equals 4 and y equals 1/2. We did encounter a few rules about distribution in the distributive property, where if it's minus a number being multiplied by an expression in parentheses, so here we have -3, then you have to multiply by -3 instead. We talked a little bit about negative numbers and how they multiply. And then finally, we talked about how sometimes it's easier to simplify equations first and then substitute. So that's all I have for you today. Next video, we're going to be continuing on with the algebra section for Meet 1. And so if you happen to watch that video, then in that case, I'll see you next time.